class. Today we're going to be looking at naming compounds. So our four things that we're going to focus on today are describe the steps to naming ionic compounds. 2, name the compound from magnesium and chlorine. Those could be any two elements. I'm just trying to give two as an example. Number 3, what exceptions are there when naming a compound with a polyatomic ion? Number 4, what do the Roman numerals stand for when using transition metals to make a compound? The transition metals are metals in groups 3 through 12 that don't have an oxidation number that's set all the time. And we had mentioned those back on our periodic table before, but we'll look at those a little more today. Okay, so we're going to be looking at naming compounds and how it works. So here's some of our steps. Most of the time you can name an ionic compound by the following steps. There are 3 steps we'll look at. First, write the name of the first element. Pretty simple. There's nothing you have to do to it. Step 2, write the root of the second element. Now sometimes this can be difficult because you're not sure exactly where the root of that element is, or the beginning or the key part of that element. And we'll practice with these enough that I think you'll get it. But sometimes I can see people making a mistake of exactly where does that root end. However, if you just write the full second element and then just add IDE to the end, then that won't work. And then step 3 is add IDE to the root of that second word. So you've probably seen some of these before. For example, sodium chloride. That's not a different element. Chloride is just showing that it is in an ionic compound. So we'll practice with some of these here. The first one, CaCl2, calcium chloride. K3P, potassium phosphide. Al2S3, aluminum sulfide. So when you see that ending IDE, that just means it's in a compound form. It doesn't mean it's a new type of element or anything. And a lot of people will ask, well, I can't find sulfide on the periodic table. It's because it's not there as sulfide, it's there as sulfur. It just happens to be in a compound at this point. Now, every now and then, our metals have more than one ionic charge. These are the elements that are in groups 3 through 12. And basically, we have to figure out what the ionic charge is. And the way that this is done is by using a Roman numeral. So a Roman numeral will be representative of the particular ionic charge for that element at that time. So you might see this written out as like tin 2 chloride. Well, the 2 in Roman numeral is showing you what the oxidation number is, because tin can have varying oxidation numbers. So as an example, iron has more than one option. So iron 2 chloride is written this way. Iron 3 chloride is an option where iron has an oxidation number of +3. Lead bromide is lead 2 bromide in this case. So you can see that Roman numeral has to be there if it is a transition metal. Only if it is a transition metal. And then we also have the problem with polyatomic ions. Now, polyatomic ions actually are probably the easiest to name in that you don't change the name of the polyatomic ion at all. So you write the name of the first element, which might be a polyatomic ion. You just write it as it is. And then on the second element, you just write the polyatomic ion name as it is. So a couple examples. Iron hydroxide, iron 2 hydroxide, because iron is a transition metal. And the hydroxide, you just leave it as it is. Calcium phosphate, phosphate is a polyatomic ion, and you leave it the way it is. Sodium sulfate, and you just leave the sulfate the way it is. You don't change the ending. So polyatomic ions are probably the easiest to write because there's no change in its name. This will end our naming compounds, and it also is the end of Chapter 5 notes.